Hi everyone, and welcome back to our next video. In the last video, we looked at our first example of building an equivalent circuit using Thevenin's theorem. We're going to do the same here. Let's do another example. So let's take a look at this one right here. Here is our circuit here. It's got one voltage source here. This is 48 volts. So let's just go in and label this here. So this is 48 volts. And R1 is 2K ohm. R2 is 6K ohm. And R3 is 8K ohm. And the load resistor is 7K ohm. So we want to figure out the Thevenin equivalent circuit. So eventually what we want to get is something that looks like this. So let's draw it in. We're going to have one voltage source, which is the Thevenin voltage. We're going to have the Thevenin resistance. And then on here, we're going to have a place where we can connect the load, whatever resistance that is. So we can call that RL. I want to be able to hook a resistor on here like so. So that's our goal. We want to take this circuit here and simplify it down so we get a very simple circuit like that. So let's start. Step number one, if you go back and look at the steps, we need to remove the load resistor. So step one, remove the load resistor. So it's going to look like this. So this is 48 volts. This is 2K ohm. This is 8K ohm. And this is 6K ohm. Since we removed the load, there's nothing connected over here. We've taken out that 7K ohm resistor. So that's the first step. Step number two. What we're going to do is now find the current running, which is running from here to here and back to here. Because we removed the load resistor, there's no current flowing over in this part here. So let's figure out what that current is. So current is equal to voltage over resistance. So that's 48 volts divided by 2K in series with 8K. So that's going to be 10K ohms. Change that 10K ohms to 10,000 ohms, and 48 divided by 10,000 ohms comes out to 4.8 milliamps. So I've got 4.8 milliamps of current. Next step, what I want to do is find what the drop is across that there, because that's going to be my Thevenin voltage. So then the Thevenin voltage can be determined by taking that current and multiplying by that resistor. In this case here, it is R3. So I'm going to take 4.8 milliamps and I'm going to multiply it by that resistor, which is 8K ohms. So grab your calculator and multiply that out. And that comes to 38.4. So that is 38.4 volts. And that voltage drop across this resistor is the same as that drop right there in that open space, which is your Thevenin voltage. So the Thevenin voltage is 38.4 volts. So that's going to go over here. This is 38.4. Step 3. We're going to short the voltage source. So when you short the voltage source, it's going to look like this. Where this, oops, I've got an extra resistor in there, sorry. This goes like this, this is here, and this goes like this, like so. And if we label this here, this was 6K ohm, this is 8K ohm, and this was 2K ohm. What you want to do is find what we call the Thevenin resistance. That's the resistance as if you were looking in this way and hooking across this way. When you look in this way, if you could push current in this direction right here, you would see a 6K ohm resistor in parallel with a 2K and an 8K. So the Thevenin resistance is equal to 6K ohm in series with a 2K, and this is the symbol for parallel to, in parallel with 8K. So this is 6K ohm plus, figure out what those two things are in parallel. That's going to take a minute to do that, and what you're going to find is it comes out to 1.6 K ohms. So our Thevenin is equal to, add those two together, and that comes out to 7.6 K ohms. So that's what this is right up here. The Thevenin resistance, 7.6 K ohm. Now, what we can do is we can insert that load into here and find the load voltage. What's the drop across that load? Well, remember from the original up here, here it is right here. The load resistor was 7K ohm. So now I'm going to put that right in here. I'm going to put that 7K ohm right in that spot right there. So let me just create a little more space here. And there, I'll just make sure we can still see it all. So there. And let me just grab a different color here. So then the circuit's going to look like this. We've got the Thevenin voltage, which we determined to be 38.4 volts. The Thevenin resistance we determined to be 7.6 K ohms. Inserting the load resistor, which was 7K ohms, would look like this. Now I have a much easier circuit to work with, and I could figure out the current going through the load. The current going through the load is going to be found by taking 38.4 volts, and divide by the two resistors which are in series, which is going to be 14.6 K ohm. Grab your calculator. 38.4 divided by 14.6 gives you 2.63 milliamps. So that's the load current. That's the current going through the load. I could figure out the voltage through the load if I take that load current and times it by the resistance of the load. So let's make a little more space and put that in here. So you get VL equals 2.63 milliamps times the load resistor, which was 7K ohms. Convert that to amps, convert that to ohms, and then multiply it out. And what you're going to get is the load voltage is 18.4 volts. So there, we used the Thevenin equivalent circuit to find the drop across this resistor here. That's the load voltage, came out to 18.4. And again, the reason why we did that is it's much easier than trying to determine it in this circuit here, where we have a much more complex circuit. Much easier if I had the Thevenin equivalent, which is this one right here. I can determine the load voltage much easier. So try some of the examples in your workbook and come and see me if you have any questions. That's it for this video. Thanks for watching. We'll see you next time.